Hi everyone! We are students from UTM Chemical Engineering. We hope you enjoy the video we prepared to introduce our course, Chemical Engineering.
What is engineering? Engineering is the application of science and mathematics to solve real-world problems for a more convenient life. Here are some examples of engineering that we see every day. Chemical engineering, mechanical engineering, electronic engineering, civil engineering, and so on. But what is chemical engineering? We invite Dr. Zaki Yamani Zakaria to share information about chemical engineering. He is an accomplished engineer who is currently a senior lecturer and research officer in UTM.
Chemical engineering is a branch of engineering discipline that involve or relate to design and operation of certain industrial or manufacturing products, which we need to add value to certain raw material to make it become a better material.
Basically, we combine the three major disciplines of science, which are physics, biology, chemistry, with maths, and we get chemical engineering, which is also known as universal engineer. We can work in manufacturing, mainly in chemical processing plant, and ensuring the quality of products with the lowest cost. Here are the differences between a chemist and a chemical engineer. A chemist mainly works in a laboratory, focus on chemistry and its theory, as well as do research and lab work. On the other hand, a chemical engineer works as an engineer in various fields, multidisciplinary, and needs application of knowledge in industry.
Chemical process is a method to change one or more chemical compounds into others and may involve chemical reaction. Engineers will have to expect and calculate the amount of materials needed and ensure the chemical plant built is suitable. In one way or another, making cookies is similar to a chemical process. Both measure the amount of materials, then we mix it and bake it at a suitable temperature and time, just like a chemical reaction. And finally, we get cookies or chemical products.
Oxidation reduction, hydrogenation, hydrolysis, hydration, and halogenations are examples of chemical reactions, and we have to master them as a chemical engineers. Absorption is a process of mass transfer of compound from gas to liquids. For example, the exhaled gas from the factory undergo absorption to filter it before release to the surroundings. Distillation is separation of components in liquid using boiling and condensations. Separation of crude oil to become petroleum, natural gas, and so on is an example of fractional distillations.
For example, if we have a palm oil tree, then we extract palm oil from the fruit of palm oil tree. So we use that palm oil to create many other products. The palm oil that we extracted from the fruit will be called crude palm oil, CPO. This CPO is a red color solution and we add value to it because it has numerous values. So chemical engineers will process it to become many other products. For example, CPO can be processed to become RBTPO, which is refined bleached deodorized palm oil and is very useful to create even more products. RBTPO can be further processed to become olein, as cooking oil, as stearin, which we use in margarine. There are many other products that can be made from palm oil with shortening and oleochemical plants.
Another prominent example of chemical process is crude oil refining. When the crude oil is extracted from the ground, it needs to be transported and then refined into petroleum products. Those products must then be transported to end-use consumers or retailers, like gasoline stations or the company that delivers heating oil to your house. The overall well-to-consumer supply chain for petroleum products is often described as being segmented into three components, which is upstream, midstream, and downstream. Upstream is the oil and gas exploration and production. Midstream is transportation and storage. Downstream includes refining and marketing. Petroleum refineries are large-scale industrial complexes that produce sellable petroleum products from crude oil. The basic functions of the refinery can be broken down into three categories of chemical processes. The first one is distillation, which involves the separation of materials based on the differences in their volatility. This is the first and most basic step in the refining process, and it is the precursor to cracking and reforming. The second step is cracking. It involves breaking up heavy molecules into lighter and more valuable hydrocarbons. And the last step is reforming, which involves changing the chemical nature of hydrocarbons to achieve the desired physical properties and to increase the market value of those chemicals.
As we mentioned before, chemical engineers are called universal engineers and work in almost every industry field such as energy and utilities, food and beverage, biotechnology and pharmaceutical, industrial chemical production, and metallurgy. But where do we actually carry out our work? We do them in laboratories, offices, and industrial plants. Let's hear from Dr. Zaki again on his experiences in the field.
When I was actually a practicing engineer, I experienced many new things on a daily basis, which I feel very interesting and I feel very alluring. I feel very excited because every day is a new day for me. One day I am doing this project, and then even though next month I will be doing the same project, but I will have different problems or different approaches or many situations. So the situation is different. Sometimes in a different occasion, during a plant shutdown, chemical refinery plant shutdown, we need to box up. We need to open up the reactor, the pipeline, the distillation column, and then we enter inside it, and then we clean it, and then I experience being inside a deodorizer, a mixer, a distillation column, and then in another day, I was working in front of the boiler house, and then suddenly the boiler exploded. So definitely that's another interesting experiences. So I can say the unexpected things happening, the information, the technical knowledge, the challenges makes me very passionate about my chemical engineering field. So even though now I am actually a lecturer, an academician in university, still I am fondly attached with other companies in terms of doing consultation with the companies. So we academicians still can be pretty much in touch technically with chemical engineering if we engage with the companies. So as a consultant.